Today's lesson is on zero and negative exponents. So before we begin that, I want to do a little review of the three topics that we've talked about so far about exponents. So if we are multiplying and we have the same base, we simply add the exponents. So this x times x to the third becomes x to the fourth, because remember, if it's just a variable without an exponent, that's really a 1. If we have division with the same base, we subtract the exponents. So we keep the base, and then we would do 8 minus 3 here, which is 5. And then if we had a product of powers, so if we had t squared and then that to the fourth power, we would multiply those. So that would become t to the 8th. And our other one was if we had something with the same exponents but different bases. Let's see, z to the second. We would simply multiply the bases, so y times z would be yz, and then we would keep the exponent of 2. So if, let's say that was numbers, we would have 3 squared times 4 squared. We would do 3 times 4, we'd get 12, and then we would keep the 2 as the exponent. Okay, so that's a review over the things that we've talked about so far with exponents. Now we're going to move on with a zero exponent and negative exponents. So simplify 5 to the 0 power. So there's a rule that says any power with an exponent of 0 is equal to 1, and that is right here. So anytime the exponent's 1, anytime our exponent is 0, our answer is 1. Okay, so if we move down here, we have 5 to the 0 power times 5 to the 4th power. Well, that 5 to the 0 power is really a 1, and then we have to times that by 5 to the 4th power. Well, anything times 1 is itself, so this answer would be 5 to the 4th power. Okay. So simplify g to the 0 power. 1. Complete these examples. 12 to the 0 power. 1. Exponent 0. The answer is always 1. So over here, the middle problem, I'm looking right here, the answer is 1. We have to come up with our own problem. So it does not matter what we pick. We could pick x to the 0 power. We could pick 1,025,033 to the 0 power. The answer is still 1. So this one can be anything as long as the exponent is 0. And our last one here in this line, negative 7 to the 0 power, is also 1. Okay. Now we have to complete this equation. 6 to the 5th power times 6 to the negative 5th power. So our base is 6, and if we add the exponents together, 5 plus negative 5 is 0, and then we have 6 to the 0 power, so the answer is 1. So this simplifies down to 1. So you already know from last year that a number times its reciprocal is equal to 1. So for an example here, and I'll rewrite this so it looks better, 3 times 1/3, and if we need to make 3 a fraction, we would just put a 1 under it, is equal to 3/3, which 3 divided by 3 is equal to 1. Okay, so complete this equation, 6 to the 5th power times 1 over 6 to the 5th. So we have 6 to the 5th power times 1 over 6 to the 5th. So I'm going to make this a fraction. When I multiply across the top, I get 6/5. When I multiply across the bottom, I get 6/5. And there's a review. We're dividing with the same base. So we're going to keep the 6. And 5 minus 5, since we're dividing, we have to subtract those exponents. 5 minus 5 is 0. And 6 to the 0 power is 1. Okay, this looks very similar to what we did up there, but now we have a negative exponent. 6 times 6, so we keep the base, add the exponents. 5 plus negative 5 is equal to 0. So that is equal to 1. And we just did this one, 6 to the 5th times 1 over 6 to the 5th. And we ended up with, remember, 6 to the 5th over 1 times 1 over 6 to the 5th was 6 to the 5th over 6 to the 5th. Subtract the 5s, we get 0, and that is equal to 1. Then 6 to the negative 5th, we are going to have to get rid of that negative exponent. So we simply make it a fraction with a 1 on top. This goes to the bottom, and that negative exponent becomes positive. So whenever you see a negative exponent, you automatically think, I have to make it into a fraction, and that will make the exponent positive. So complete these examples. 10 to the negative 6, automatically see negative exponent, so I'm going to put 1 over, and then this is going to go at the bottom with a positive exponent. Same thing here, negative 34 to the negative 7th, I see a negative exponent. I don't care that this is negative here, I'm only caring about the exponent. So negative exponent, automatically make a fraction. That negative 34 will stay negative, but the 7, the exponent, is what becomes positive. So this is a very important one here. Make sure you pay attention to that. Only the negative on the exponent disappears. This one gave us the answer of 1 over 142 to the 13th. What was the beginning problem? Well, I see that fraction and I see this exponent became positive. So flipping it around, going backwards, we must have started with 142 to the negative 13th power. So here's kind of the definition for what we're doing. In general, for a power where the exponent is a negative integer, n to the negative a power is going to be equal to 1 over n to the positive a power. And then we have 4 problems here for try it. I see a 0 power here, 455 to the 0 power. That answer is 1. And then I see c to the 0 power down here on the third problem. So I know that answer is 1 as well. The other 2 problems we have left, I notice, have negative exponents. So I know I'm going to start off with 1 over something. We have to make that fraction. And for the second problem here, our 19 and our negative 4 then becomes positive 4. And for the last problem, we keep the k and that negative 2 becomes positive 2 exponent.